Hello there and welcome to Binomial Distributions, How to Use a Calculator Function Properly Part 2. This particular video is going to emphasize some of the logic behind calculator functions, more specifically how to read these calculator functions so you never have to worry about them again. For instance, a PDF function, PDF, involves when x equals a particular number. Well, more specifically, when we're using these calculator functions, we want to know when the probability of x is that number. So there aren't a whole lot of key phrases to really worry about this particular system, except the two following words, exactly and equals. Now, anytime you see this phrasing within a binomial question, you automatically know you're working with a PDF. So that's nothing really too hard. But when you strip these words away and you use an inequality, then we're going to get stuck with a CDF function, CDF. Now, CDFs in their own unique way involve using the probability of x being less than or equal to some number. So again, you still have your key phrases. You have your at most, which is a common one, no more than, very common on exams, and you also have your less than or equal to. So these particular phrases you want to get very used to, because not only are you using them in regular everyday logic, you're also using them in calculator logic. So just to make sure you're paying attention, all binomial probabilities must be converted to a at most probability, regardless of the problem. Now, this is if you are dealing with less than, greater than, less than or equal to, or greater than or equal to. And if you're working with a CDF function. So if it's a PDF, you really don't have to worry about it, but it's the CDFs that you really need to worry about in the long run. So if you've been watching my other videos, you should know a few properties of binomial distributions, or more importantly, properties in statistics. For instance, your x variable has to be between 0 and your sample size. Your sample size has to be a number bigger than 0. This is implied within statistics. And more importantly, the probability that x equals some number is your binomial formula. You know, the sample size, choose a number, probability of success, and that many successes, probability of that many failures. This is stuff that we've covered in our previous videos. If this stuff looks brand new to you and you haven't seen it before, then you need to go back to one of the first videos in this series and look at the binomial formula. Binomial formula. And we're going to be using this over and over again within binomial properties and binomial distributions and binomial probability distributions. But when it comes down to the calculator functions, we tend to forget this formula. It's very critical that you try to keep this somewhere in your arsenal. So if you have seen that formula for the first time here and you want to continue and press forward into this video, well then the binomial formula is just the combination of ways something can happen. I-O-N Alex, make sure you spell that correctly as best you can. The likelihood of success and the likelihood of failure. Wait a minute here. Red flag. This notation was used earlier in this video. The binomial formula is the exact same function that a PDF in your calculator would use. So if you're dealing with binomials and you're dealing with a PDF, you're doing the same level of math in your binomial formulas. It just so happens that this notation and this formula are the same as this, right? No, it's not. It was designed that way. So doing a PDF for some people may be quicker to do in this fashion than by using the calculator. It depends on the student. But the only reason why we can use this notation is because of that key phrase equals. So because it's an equals or exactly, we have a PDF function. So what if we wanted to use a CDF function? Well, my apologies folks, but because of the length of this video, the CDF functions are going to be in the next part, and the CDFs are going to take a lot more time than discussing PDFs. So we already went over the basics behind one of the functions, and I've gone over them continuously in previous videos. Now we just need to attach the actual calculator function to it. But the CDFs, on the other hand, are going to take a lot longer, because when you're dealing with CDFs, you got to convert a less than to at most. You got to convert a greater than to at most. And most people don't want to see the connection behind these two sets of information. Well, we'll deal with that when the time comes. And don't forget to visit tallguymath.com for all information leading up to my videos, as well as for question support. Thank you very much, folks. This is the Tall Guy, signing off.